Hello everyone, we are Team 17 and our project name is DKOMP and we are working with DComplex. My name is Gauri.
I'm Amrit.
I'm Zach.
I'm Eric. So for the project description, we're working with DCOMP, which stands for Decomplex Organizational Management Platform, and their service is designed to improve internal company transparency. And what Decomplex noticed was a discrepancy between role complexity and employee capabilities, where only 23% of employees are engaged at work, which leads to an 8.8 trillion loss in productivity. So to help combat this, Decomplex tasked the front end team to implement a feature for managing individual performance assessments, or also known as IPAs. This allows managers to track employees' performance over time. And additionally, Decomplex faced security issues, and stability concerns that they wanted the backend team to address. For example, there were no checks allowing employees to access any part of Decomp.
The approach we are going to follow in this entire project and we did was following software development lifecycle methodology, where we perform minimum 2 code reviews per every pull request, where there were at least 3 which were recommended. And we always develop new features on a separate branch so as to have a clear code review performance.
So for sprints, there are 3 sprints and they last 2 to 4 weeks each. And these sprints have one major goal and many subtasks.
So for what we learned, we worked hands-on on an enterprise development workflow, which allowed us to work on a large-scale software project and develop best practices for code quality. We gained experience or practical experience with the Scrum Agile framework, which included things as participating in daily stand-ups, sprint plannings, and retrospectives, allowing us to do continuous development. We also implemented role-based access control using the Microsoft Entra Security Suite, giving us a deeper understanding of managing user identities.
In addition to that, we also developed our technical writing skills by making sure to add documentation to help in the onboarding of future developers. And also we gained knowledge of advanced React concepts and tooling, including a library that was new to all 4 of us called React Flow.
So for front-end deliverables, we implemented the IPA table and the individual IPA screen, which allows users to create new IPAs and edit existing ones. And in the table below, you can see that it displays the name, status, quarter, year, role, current IPA date, recent IPA date, and direct manager. And this information is being displayed from CRM.
And we also created a role specs and individual role spec screen for which there is live data which is being displayed right at the second picture at the right hand side of the screen, which displays the role specs table, which has different columns which are kind of similar to the IPAs, which talk about role specs, position, and different types of accountabilities, which is also related to an sitemap which can be expanded and retracted as per the user's convenience.
For the backend deliverables, for the first sprint, Zach and I were given security requirements that needed to be addressed. So we researched and found that role-based access control was the best approach, and we presented our findings during our security proposal. Throughout the second and third sprint, we implemented role-based access control throughout the application, which included things such as creating the depth first search algorithm that allowed us to find the direct and indirect manager of an employee. We also added measures to prevent unauthorized users to make or move connections between nodes. And then, for example, if you can see in the graph, the CEO has control and can move anyone below him, which includes a tech lead he's a manager of and an indirect manager of everybody else. But the project manager could only move or edit the software engineer and nobody else.
To add on to that, or rather to implement that, Eric and I had worked on a workflow for making sure to authorize users anytime they're trying to perform some protected action. So for example, if someone's trying to move another user, then the front end will check and ask the back end, is this user a member of the administrator group? The back end uses Graph API and Microsoft Entra groups to determine whether or not the user belongs to that group. If so, great, then it'll return true, and then the action is accepted, they'll be moved. But if not, the backend returns false, and then the front end will ask another question. is the user a manager of the node that they're trying to move? So for this part, we use Eric's implementation of depth first search on the graph to determine if there's a direct or indirect connection between them. And then if so, the backend will return true and they'll be able to move them. If not, then the backend will return false and the action will be rejected entirely. In addition to this role-based access control, we made sure to add documentation to express controllers as they were pretty confusing initially during the onboarding phase. So we really wanted to help future developers. And then also Eric added audit logging for any time that nodes are repositioned, saying when they were moved, by who, to what position, and so on. We would also, as our presentation is coming to a close, like to extend our gratitude to our mentors at DKOMP and to the faculty at CSUMB. They have provided us for a long time with the tools and opportunities necessary for us to not only develop our technical and interpersonal skills, but also for us to feel like we're ready to thrive in professional development environments.